Welcome to Unit 4 and the topic of process analysis. For your orientation, we are in the middle of week 2, and before we get started, let's recap on what we've learned in Unit 3. What were the key takeaways of process discovery? Well, at first, we've talked about that process discovery is the gathering of process models in an organization. Then we covered the most common approaches to discover processes, which are interviews, workshops, and the collection of evidence. We then talked about process modeling and what the most important governance topics are in this phase. We talked briefly about the new topic of journey modeling and which of the SAP Signavio suite products can best support the activities in process discovery. Finally, we sneaked into the overview of SAP's golden standard and the 4D process modeling approach. Now let's kick off Unit 4 on process analysis. After processes are modeled and their dependencies are defined, it is time to ask ourselves, how well is this process designed? Is it running efficiently and effectively? Is it still state-of-the-art? Are there technologies in the market that can improve the process and its customers' experience? Well, we can use quantitative and qualitative techniques to analyze a process. I will explain what that means in a minute. The outcome of Phase 3, process analysis, is still the as-is process model, but also a list of process weaknesses or, positively spoken, improvement potentials identified. There are many ways to find out how well processes are running. Sometimes it even helps to talk about it with the people carrying out the process. They usually know exactly where the improvement potentials for a process is. But there are also cases where a more structured and academic approach is even better. Let me briefly introduce you to the 3 most commonly applied qualitative techniques to analyze a process: value stream mapping, waste analysis, and root cause analysis. VSM is a lean manufacturing technique used to visualize and analyze the flow of materials, information, and activities needed to produce a product or service, and it typically involves cross-functional teams. By creating a visual representation of the entire value stream, VSM helps teams to identify bottlenecks, delays, and non-value adding activities, such as excess inventory, overproduction, and unnecessary transportation. It also helps to identify opportunities for improvement, such as reducing waiting times, improving quality, and increasing productivity with the ultimate goal of actually increasing customer satisfaction. The second type, waste analysis, is a method to identify areas of inefficiencies, wastefulness, and non-value added activities. The goal is to identify any activity that does not create value for the customer. The waste analysis typically focuses on the 7 types of waste: overproduction, waiting time, transportation, processing, inventory, motion, and defects. By identifying and eliminating these types of waste, organizations can reduce costs, improve quality, and increase productivity. The last one, a root cause analysis, is a systematic approach for identifying the underlying cause of a problem, defect, or incident in a process or system. So instead of just addressing the symptoms, the goal of RCA is to identify the fundamental cause of a problem to actually prevent it from happening again. In lean management, it is also called the Ishikawa diagram, but you may have also heard of the 5 whys or the fishbone diagrams. Those techniques are often used to identify possible causes of a problem or incident. Let's take a look at some quantitative techniques to analyze processes. Process mining is a rather new technology which uses data from event logs to visualize and analyze processes. Process mining helps organizations identifying bottlenecks, inefficiencies, compliance issues, and other problems on just a few mouse clicks. Since process mining is a fundamental element of next week's presentations, I won't spoil it too much for you, but I can tell you it is a game changer for all system traceable processes. Process simulation is a technique that simulates the flow of a process comparing different scenarios. It allows you to display and run a process changing parameters like number of employees, hourly wages, process automation, and many more. It shows the impact of the change before actually implementing them, which may save lots of time and money and leads to the perfect result possibly attainable. Now that we've analyzed processes, what are we going to do with all these improvement potentials, inefficiencies, or pain points? How do we know which ones are the most important ones to tackle? If we don't have a clear system at hand like Signavio, which prioritizes weaknesses and provides improvement recommendations, we need to find a way to do so manually. I gathered some of many possible criteria to determine the impact and urgency of potential process improvements. Most importantly, of course, is the customer or employee value, which the improvement would lead to. For all profit-oriented organizations, the financial benefit must also be very important criteria. Over the past 5 to 10 years, the topic of social and environmental responsibilities has become more and more important, and it should also be considered in your decision. Also, taking a look at the implementation effort makes sense. We all know about the famous low-hanging fruit, which might not have the greatest impact, but seem to be feasible with very little effort. And last but not least, I would like to mention that the need for external support is also something that you should consider. Can we implement the change with internal knowledge or resources? Because external resources are more cost-intense, less flexible, and might create a long-term dependency. So I've mentioned process mining and clever systems to support identification of process weaknesses and prioritization of improvement measures. And again, you will learn all about it in more detail next week. But just so you've heard about it already, I wanted to introduce you to SAP Signavio's process analysis and mining solutions. They consist of two great SAP Signavio suite products, Process Insights and Process Intelligence. Process Insights is a built-in analysis of SAP ERP Central Component and SAP S/4HANA systems, which means it can be leveraged already by SAP ECC customers. It delivers insights on process weaknesses and curated process improvement recommendations on only a few mouse clicks. Process Intelligence is SAP Signavio's process mining solution, which can be applied for all processes, leaving a digital footprint, and delivers a completely new visibility into the real process execution and process inefficiencies. Here's a screenshot of the correction recommendation for the plan to fulfill process. I know you won't be able to read all this, but we've just talked about prioritization of improvement recommendations. As you can see, Process Insight detects finding, counts the number of occurrences of the specific finding in the process, forecasts the impact, effort, and value, and recommends a specific correction to the finding. Pretty cool, isn't it? All right, let's see what other products of the SAP Signavio suite will be able to support the activities during the process analysis phase. We have the Process Manager, which is not only one of the leading process modeling solutions, but also contains a process simulation feature. The Journey Modeler to attain the inside-out view on a process. And of course, the two products for analysis and mining, Process Insights and Process Intelligence. Now, let me wrap up Unit 4 by summarizing our key takeaways. In the beginning, we have talked about what the elements of process analysis are. We then talked about the most common process analysis techniques and the technology available to analyze processes automatically. We also talked about which solutions of the SAP Signavio Transformation Suite can support process analysis, and finally, some of the most critical success factors of process analysis. Thank you for your interest and attention, and I hope to see you soon in Unit 5.